Alright, essentially the free response on this question, or this test, there's 3 of them. Here is one. I don't have my usual computer, so I had to just kind of do this a different way and just scribble it out. So you can see everything here except for the actual problem. But just check this real quick. It says given the following reactions and the delta H values. So this is just simply a Hess's law question. So if you can do Hess's law, describe it. So that would mean like you double the top, reverse the bottom, leave the third alone and add, or something like that. That's just, you're going to write how you do it. Then you're going to tell me whether it's endo or exothermic, and that simply is, if it's a negative, it's exo when you do the math. If it's a positive, it's endo. Then this will be what the actual answer is. That's part C. When you do all that math, letter D, make sure that that's as easy for you as it's intended to be. It's worth 5 points, and really all you have to do is remember that the reverse reaction has equal value but opposite sign. Then write the reaction in words. That would be for the overall reaction. And I will tell you, I've given this since 2008, and this is actually always the lowest part of this test. So you can't see what these things are here on purpose, but I think I've had 10 kids out of probably the 200 that I've taught that get that right. It's not that hard. It's just a little bit hard to remember. Now, I no longer make this part extra credit. It's part of the test. If the answer above was negative 1250 kilojoules, how much energy would be released if we use this process to produce 1 cup of water? Alright, so there's one thing you can tell. Water must be a product. This is just finding Q again, but you have to use the conversion. 1 ounce is 29.57 milliliters, and that's a little bit different on your actual test. But it's something similar. Alright, so this is one of the 3 types. This is the second type of problem you'll see in your free response. And it just reads, when the 2.88 gram sample of that thing is added to a certain amount of water, the temperature drops, and it gives you the 2 values there crossed out again. And then A says give the balanced dissolution reaction. Now, what I mean by a dissolution reaction is if I were to put NaOH plus H2O, I would just form Na plus OH minus, because really the water just makes this separate, so you can just put that dissociating into its ions essentially. Alright. B, besides that the problem tells you, how would you know this substance dissolves in water? That has something to do with the solubility rules. Then this is where you would actually solve, and it's the kilojoules per mole. So this is a calorimeter problem. It tells you that right there. So that means you're using Q equals SM delta T. So you are going to solve for that, but remember I'm only giving you 2.88 grams. So you would have your 2.88 grams. That's supposed to be an 8. Divided by your molar mass to get it in moles. And you take your answer and divide it by this number. Hopefully you remember what I'm talking about there. All this. Alright, now, is it endo or exothermic? Once again, that has to do with the sign that you'll get here to your Q. If this substance was added to a solution, would there be a precipitate? So the thing we're adding here, you need to know how its solubility is affected and if a precipitate would be formed. And then number or letter F, your hot, whatever, your calorimeter out of your hot chocolate cups, and that should be an easy problem. So hopefully this one isn't a problem. If you have issues with part C, check with your lab partner and see if they can help you out. Do some homework on those or look in your notes. Then I've shown you this problem a couple times before, so I'm not too worried about you seeing it. I'll change a couple things. But this type of problem, give the balance reaction, and I'll probably change it. I might not, but I probably will. So you would just write it out from here. That would be A, B, using the table. The hard part of this is to make sure you have the right formulas so you get the right values. If you have the wrong formulas, you'll get the wrong values and you'll get everything wrong. So study these oxides and remember to drop and swap when you find their formulas. Then, this is from previous chapters. Which element is oxidized? That's your loser of electrons. So look for the one that became more positive. Alright, then D, if 12 grams of this were added to excess, what would the limiting reactant be? We've already gone over this one in class a little bit. Don't fall for it. It's supposed to be easy. Then part E is actually the answer that we would have done from this table a long time ago. Maybe not, I'm sorry. Oh, sorry. So we got our answer up here. And then we're going to use that answer up here that we would have with that mass converted to moles. When you find out how many moles 12 grams is, then you can just multiply that, and it's not too hard. Once again, we've done those in your notes. You can review or check your homework. Now, there's more to this question. I'll go look or go get. So this is the last little piece of this. It says if this reaction were to take place in 1,000 milliliters of water, and this is exactly what we did yesterday, what would be the temperature of the solution? Excuse me for my yawn. After the reaction had gone to completion, and then we'll assume the same thing as always, that we have the specific heat of water. And then you can always convert 1,000 milliliters to 1,000 grams of water. So we did those. Now I'm making this on Thursday night, so we did them earlier today, but to you it would have been yesterday. So those are the 3 free response type questions for this exam.